My name is Sjoerd Jong. I'm the evangelist for the Unreal Engine in Europe, and I'm going to talk about volumetric lighting and fog. Which means, following, we're going to talk about recent changes that we've done regarding this. Then we're going to talk about simply how to enable it, just the very basics. We're going to talk about configuring and understanding it in general, and also how it's being affected by lighting and shadows. And then we're going to move forward. We're going to find out that that's actually not good enough. So we're going to move forward by making local volumetric fog clouds to further enhance it. I'm going to wrap up with a brief look at a more advanced setup of all of this. Good. This is what we want to build. So we have a beautiful little nature scene here. That is the level we have here on the other side, on the other screen. I'm going to put that to on lit mode, no lighting. You can see we have a deer here. We're going to have sunrise, and that's essentially what we're going to work with. Good. Now we're going to start very, very basic. We're going to simply add light to the environment. So I'm going to go to lights. I'm going to drag in a directional light. I'm going to put the viewport back to lit mode. And this is the sunlight. So the directional light is the sunlight. If I rotate that, obviously it changes, and so on and so on. There's not too much to say about this. It's pretty straightforward. Add a light. That's it. The reason why I bring it up very early now is because later on I'm going to change some of the settings we have in the directional light, because that's going to be important for the fog we're going to add. Okay? But for the time being, nothing more to say, so I'll just add the next one. We have a skylight, and a skylight is the indirect lighting. So the directional light, that is the sunlight itself. That is the light that comes directly from the sun. The skylight is the indirect lighting. So that's the light from the atmosphere. The sunlight that gets caught in the atmosphere of the planet, gets bounced around, and then comes from all different directions back to the surface. And we can see this work if we disable the sunlight, the directional light, for a second. So I'm disabling that. I go to the skylight. I'm going to bump up the intensity quite a bit so you can see what's happening. And you can see we have this. And the reason we have this is because the skylight actually captures a picture, a cube map, of the entire surrounding geometry. Now the surrounding geometry usually meaning the sky itself. Okay, so essentially it takes a picture of this. And then it uses that picture to project the lighting back down. So the lighting that gets projected onto the world is actually a picture of the sky projected downwards. Which means if the sky is orange on one side, like here, and blue on the other side, then the light is going to reflect that. So we go back to the level here and we switch to lighting only. You can see this happening. See, it's orange here, bluish there. So it's quite nice. Now, it already did that for several years, so there's nothing too new about it, nothing too special about that. But recently we've been improving that further because it wasn't good enough. So things we've recently done was we've added multiple skylight bounces, improved skylight precision, and volumetric light maps. Now what it all means is following. So first of all, it's more precise. You can see the image is going to switch in a second. This is how it used to be. It's very uniform. It's not very interesting. This is what it's doing now. So it's simply got more precise. You get more richer colors, more variation in brightness. And that's happening by default. If you're using 418 or 419, it simply happens. Okay. Then secondly, we have more skylight bounces. So before we change this, the skylight can only bounce once. Okay, so the light from the skylight comes in, it hits the surface, it bounces away, and that's it. It does one single light bounce, and that's it. So it wasn't particularly, that's not enough. So now we changed that so that if you go in the world settings, let me drag it out a bit, it says there's a setting here called number of skylight bounces. So you can now configure it. I set it to 2 because in this environment you don't really notice it that very clearly that it's bouncing a lot, but you can now configure it. And because of those two changes, you can do crazy stuff. For example, this setup you have over here, this picture. Imagine that this is the sky. It's a very strange sky, but just imagine for a second that this is how the sky looks, okay? And then we made a box. This is a box inside the box with a small hole in it. You can see that's the hole in the box. The light is actually precise enough to bounce itself into that hole, back into the surface inside, hit the wall on this side, and project itself. You can see that's the face of the person there. Upside down. So that's like a 19th century pinhole camera. It's simulating a camera. It's a game engine. And we can get this more precise if we shrink the size of the hole. That is crazy. And it's completely useless for games because you will never do this. It took half an hour to render that little cube here. So you would never do that. But the fact that if you would want to, you can do it is awesome. Okay. Anyway. The third change, and this is actually the most important one for us right now, is volumetric light maps. Now exactly what it is I'll show you in a second. Let's first focus on the difference. The left picture is how it used to be. The right picture is what it is now. Again, the lighting is richer, more variation, and so on. The challenge that we have in real-time rendering, not just in Unreal, just in general, is that if we bake the lighting into the environment, okay, so if the lighting has been baked and pre-processed into light maps, and if you then have dynamic models that go through the environment, such as a character or weapons, vehicles, monsters, enemies, anything that's moving through the environment, then how do you figure out what the lighting is for that model? Because you couldn't have baked that, because the light was already baked. So how we did this in Unreal Engine 4 up to a couple of months ago is we placed an indirect lighting cache, which is essentially a large grid of lots of points. So there would be a point here, point here, point here. We simply cover the world in points, and every point remembers this much light here, this much light here, this much light here. But it wasn't very precise. So that's what's happening here. You can see it's not precise. We've now changed that with volumetric light maps, which means following. I'm changing the level to the exact same level with the lighting already there, okay? So it's just the same setup. And you can see here, if I go to show, and then visualize, and then volumetric light map, it shows this. Now this is crazy, do not do this at home. Okay, what I did here is way over the top. It was for the sake of the demo, I bumped up the settings way up. So the density of those little spheres you see is much higher than it probably should be. It's probably a bad idea to do this in a game with this density, but for the sake of example, it works. And even with lower density, with default settings, you would get the same, just lower density. Each of these points, you can see, just populates the world in points. Not only remembers the ambient lighting in that given location, it also remembers the direction of the light at that given location. So it remembers that there's ambient light coming from this side, which is orange, and coming from this side, which is kind of bluish. So it captures much more richness in how the lighting is stored and remembered. I'm going to turn it off, put that back to lit mode. Right, now since we have the volumetric light maps there, since we're essentially storing the light brightness and direction in the world at different points in the world, we can then use that information to apply that color and that essentially the color and the brightness to the fog itself. So I'm going to go forward and set up a very basic first fog effect. So I'm going to bring in exponential height fog. We just drag that in. We get this. Now I'm going to very quickly have to change these two numbers because later on I'm going to have to rely on that. So let me quickly do that first. And then let's bump up the density. Right, so we get this. Cool. But that's how fog used to look in games, right? This is how it always looked in games. There's nothing special about this. It's just a layer of color that's blended on top and that's blended with distance. That's essentially it. And we've grown used to that over time in games. We've grown used to this kind of look. We've grown used to the problems that this has as well. Imagine you have a forest, like we have here, with bright blue fog, like we have here. And then imagine that in that forest there is a house somewhere, an abandoned house. The moment you would walk into that dark abandoned house, you wouldn't expect to have bright blue fog inside, right? It should be dark inside. But that's not what happens with this kind of setup. You can see here, I don't have a house here, but I got a bush. So let's imagine this is a house. If you go underneath the bush, it doesn't really get dark. You get this layer of blue on top. I mean, you get this, see? That's not really supposed to happen, and we've grown used to that over the years, and it's completely incorrect. This is where volumetric light maps come in. If I, in the fog setting, go down and go to volumetric fog, and then the setting say, yes, do that, the color changes instantly, because the color is now red from those volumetric light maps that populate the world. That's why the color is now mostly orange. Now the color is also affected by the directional light, the sunlight, so for the sake of making this easier to explain it, I'm going to temporarily disable that, okay? Sunlight is off. We're only using the skylight, which in turn, because it's set to static, was baked into the volumetric light map. So this is only using the volumetric light maps. And I'm going to bump up the settings a bit. So everything I'm going to do in the next couple of minutes is going to be extreme, okay? It's going to look like a nuclear bomb has gone off. That's okay. I just want to demonstrate this, and then we'll bring it back to a more reasonable density later on. But you can see there's a bit of richness in the color. It's not just one color of fog, it's more rich. And if you go back to this bush we had earlier, you can see it actually darkens if you're underneath. It actually respects the lighting and the shadowing. And it goes really, really far. Because if I go back to the main area here, and I go to lights, and I drag in a spotlight, and there's a setting here now that says volumetric scattering intensity. So in other words, how much does this light light up the fog? So I'm going to say, okay, you know what, that should be probably pretty high. Let's do 20 or 40 or so. And we get this now. So the light, we now have a spotlight actually illuminating the fog itself. And it's properly, like, you know, you can actually go through it. You see it's completely smooth, no matter how you look at it. it just works. And if we have that, then we can go another step further, because this works on every single light. That means it works on particles too. These fireflies you see flying around here, that's the little particle system. There's a particle. It's a very simple particle, but it has a light module in here. So every particle is casting a light. So if it's casting a light, we can make the light also affect the fog again. So here we have radius scale. I'm going to change the radius to something bigger. You can see what you get here is this. It's actually lighting up the fog itself as the particles move through. Now the settings are a little bit extreme. Maybe I should do a bit less. Maybe something like that. But imagine having a fire with embers. If the embers fly away, they actually light up the fog. Isn't that cool? And it's just a couple of clicks. You just click, click, click. Effect. That's awesome. That's what I love about Unreal. Anyway, let's make this more reasonable again. Back to what I had. And then let's take a look at the sunlight. Because what I did a few minutes ago is I disabled the sunlight, right? I disabled that one. So let's enable that again. So I'm going to say yes, enabled. You can see the fog instantly changes color again, as expected, because the fog is now also receiving lighting from the sunlight. So it's reading the value of the volumetric light maps, and it's reading the light value of the sunlight as well. That's now the color we see. But we also see these God rays. We get this. And the God rays we're seeing here is actually the shadows itself. So the sunlight is now shadowing the fog. It's receiving dynamic shadows blended on the fog. It's crazy how far this goes. So if I turn off the shadows, you clearly see the difference. It's literally the shadows affecting the fog. It's not a visual effect, it's literally the shadows. And that's really cool, but it's still not good enough. So there's two more settings you can enable to further complement this and make it even cooler. I'm going to turn off the fog temporarily, because I want to take a look at one of them without any fog present. And they're in the directional light settings, light shafts, light shaft occlusion, and light shaft bloom. Look, if I turn on light shaft bloom, I get this. See? It's kind of the same thing. You get God rays, but you get God rays by brightening the screen. So light shaft bloom is God rays by brightening. Light shaft occlusion is God rays by darkening. That's it. Brighten, darken. I have to turn the fog back on. Again, nuclear bomb went off, so ignore that for a second. But if I turn off light shaft occlusion now and then bring the intensity up or down, you can see what happens, see? So it's a similar kind of effect. You get God rays, just like the shadow, but you can use this to further complement that, and I think a blend of all three is probably the best. So now we end up with this. So cool, but it's a bit extreme, right? It's really rather extreme. So let's go back to the directional light and, sorry, the fog. You distract me. To the fog settings, and let's bring this down. Let's say, you know, maybe this is more reasonable. Maybe that's more pretty. But is it really? Because it's still the same color covering the entire screen. It's still the same density covering the entire screen. We'd like to have more control. We'd like to say, you know what, there should be a lot more fog here near the tree, but a lot less near the deer. Preferably, we have a nice composition going on, where we have a wall of fog here, like a wall of smoke coming in almost. Pretty little smoke over here near the deer, so you can properly see the deer. And then a lot more smoke on this side. We can want to control it. And we want to control the color as well, so it's not all the same. In order to do that, we're going to have to make local volumetric fog. So I'm going to scale the actual fog way down. It's now 0.1 in density, so it's pretty subtle. And I'm going to set up a material. I'm going to go to the content browser, right-click, new material. And in this material, let's bring this here. Essentially, I'm going to recreate what we see on the slides here. But you can create local volumetric fog by using the material editor and by configuring that to be a volume material. It's a special kind of material, then hooking that into a particle system, and it's then going to be rendered as fog. Okay, so that's what I'm going to set up now. That means I need the stuff I see on these slides, so let's just do that. I need to know the world position. I need to know the particle position, because again, this is connected to the particle system, and also the particle radius, therefore. I also need to simply have the value of 0. They all come together into a sphere mask, which I mistyped. Sphere mask. And then the sphere mask is a bit too intense, so I'm going to multiply it down by 0.05. So we multiply it down by 0.05, and that's it. Now the material as a whole, you can see that here, you can see the inputs there. It's still a regular material. I just made a material, right? But it should be a volume material. It should be a special kind of material. So I'm going to click away, so get the main properties here on the bottom left. And here it says material domain is surface. Let's set that to volume. That changes the inputs there. That's cool. And also we get an error here at the bottom where it says, volume materials must use an additive blend mode. Okay, blend mode, opaque, should be additive. That's it. It's just a requirement. So having changed these two, I can now hook this up to extinction. It's cool. And I have to set a color. So I'm going to set the color here to some kind of bluish, similar to what we had earlier. I know, roughly something like that. And let's apply that. Let's close that. And let's make a particle system. Okay, so I have the material assigned to the particle system. Just this is the material I just made. I'm going to say it should spawn a little bit more. This is going to be a very basic particle. It's not going to be super pretty. It's going to be flickering and you're going to see some popping and such going on, but it's going to show the basic idea of how this works. So a basic particle system that spawns pretty large sprites. So I'm going to bump up the size to 1500 and it should be spawning in a radius. So I'm going to add a cylinder for location and set the cylinder to, I don't know, 1750 or so. And that's kind of it. And again, we're going to see some popping and it's not going to be 100% ideal, but the idea will work. The moment I drag this in, we get this. See, it's literally a local cloud. You can drag that up, see? And it somewhat renders as particles, but it's not entirely a regular particle system. In fact, if I were to place this here and start flying in there with my camera, you don't see the sprites appearing. It literally behaves as the fog just looked. It looks the same, see? Except you can see some popping in and out. We're going to fix it in a second. But it's kind of behaving the same, which means we can now make local little clouds. We can say, there should be one cloud there and one cloud somewhere there. I don't know. Something like that. You see, you can make local clouds. And here's the thing. If it's using... Trying to delete these. Let's delete these. If it's using the regular material system and it's using the regular particle editor, then how far can you go, right? What can you do with it? So I got carried away when I was building this, and I spent over a day building what you're going to see. So this is what you can do if you keep pushing it. It's meant to inspire you. It's a bit over the top, but just where's the limit, right? First of all, I need to have that specific shape into it. And I can accomplish that by making a mesh like this one, which is the shape that I want to have for the fog effect. Now it turned out that it was a bit too small, so I'm going to set scale to 2. And I'm going to position it roughly somewhere there, which is kind of what I need. So, and then I have a particle made. So this is the particle I'm going to use. And I'm going to show you in a second exactly how it works. But this is how it looks in the particle editor. There's nothing special going on. This is very, very basic. The only thing that's special is this one, which is a skeletal vertex surface location. So essentially spawn the particle based on a mesh. And that's the mesh I just added, right? This one has a parameter added with this particular name. And if I go back, let's close that. If I go back to the level here, and I press, and these are the properties of the particle, I press expose parameter, it automatically detects all the parameters within my particle. I only have one. So it shows here instance parameters. See, this automatically showed up. That's the same name as you just saw seconds ago. And that asks for an actor. So let me select the floor here. That's not the right one. Let's do this again. I have the floor selected. You can see now it says SM Fog Mesh. And then this is somewhat hacky. In order to get rid of this mesh here, I'm going to add an invisible material to it. It's somewhat hacky. That could have been better still, that step. But if I now move that model, you can see what happens if I move it up in the air. We get this. See, it has a specific shape. And it has, we can go full screen here. It has pretty advanced shading. So you can literally go into those clouds and I get this. And you can kind of see there's some lighting and shading going on. It's not just a flat piece of fog. It's actually kind of billowing out or something like that. And again, if you go into it with a camera, there's no issue with doing that. It doesn't look like you go through sprites or anything else. Essentially, we get this. It also has more color variation. You can see it's clearly yellowish there and blue in other parts. So let's move that back down. Do something like this. Let's go back to window mode. And I also have a small local cloud that I'm going to place alongside of it, which is this one. Kind of the same idea, it just doesn't have a specific shape. It's just one little cloud of something. And I'm just going to drag that left and right next to it. So I think I want one cloud somewhere here. Maybe something like that. And maybe one there, and I think one in the back near the where the camera is located. And we end up with something like this. Okay. So how did I make this setup, you may ask? So this is how it works. This is the particle system you've seen a second ago as well. I mean, nothing special here. That has a material underneath. It's a material instance. That just tracks all my settings. Nothing special there. Tracks settings. There's another instance underneath. Sorry, actually, I should have taken this one. They all go to the same one eventually, but it's better to work with. And then we get the material. So this is the material I'm using, and that's the thing. If we're using the regular material system, the sky is the limit. Keep building. How far can you push this? It's material, the material editor. Same for the particle editor. And that's the really cool part about Unreal, how all the tools are tied together. So you can see what I've kind of done here, briefly going over it. First of all, I'm simulating lighting by darkening the bottom of every cloud. So you kind of get this feeling that the cloud is shadowing itself because the bottom is simply darker. Then I take this texture, which is some kind of cloud texture, show you that, which is blended on top using macro UVs, which is an existing particle function and feature. This gets blended on top, so it gives some extra richness. So it's not just a flat color of fog, but there's some extra, turbulence and such in there. Then I also brightened the inside because it felt better. It kind of simulates lighting as well, it just felt more complex. And then I fake additional God rays. So this is actually the fourth way of doing God rays. I take the texture I have over here, which looks like that. This is actually a merge map, so it should be viewed with just one color at a time. So say something like that or this. I took one of these textures and essentially I'm planar mapping the fog with a texture. So imagine you have a model and you planar map a texture on top. It would stretch out on the sides, right? So you get rays. Essentially you get lines going down. So if you were to take a cloud of volumetric fog and you project a noise texture on top, you get lines going through the entire thing. So now I have God rays. Then I rotate the projection of my planar map to match the direction of the sun, and now I have lines passing through all of the fog. So I have God rays. It's a very cheap and fake effect. I mean, it's pretty fake, and it wouldn't respect the fact that there might be shadow, there might be an object blocking the sun. It wouldn't respect that. But in general, it works pretty okay. Another thing that I did is color. So most of this kind of looks complicated, but most of this is pretty straightforward. The one thing that's special is this, because this is the color you're looking at. The fact that it's yellow in the middle and bluish on the side is because I painted this texture in Photoshop and then projected texture on top of it. So I manually colored it by painting this, and that's defining what the color of the fog is at different locations. So I had complete control. Okay, and this is just this is the same we done before with one extra setting. That's basically it. And what we end up with is then this. Now, before I wrap this up and show you the final fly-through, just a brief word about performance. Like everything, it costs something. This has an impact on performance. The performance impact is not huge, but it's still existing. The engine clearly tells you how much it costs, because if you bring up the GPU profiler, you see this is a volumetric fog. So it clearly tells you this is what we're spending on this effect. So that's reasonably big. I mean, it's the biggest bar of the whole thing. So it is pretty expensive, but if you look at the number, it's less than 3 milliseconds. So, I mean, that is doable. This is fairly powerful computer heavy over here, but it is doable. And I'm doing this in the editor, which is affecting the accuracy of this. And I'm doing this with the most complex setup you can probably do. I have an advanced material in there, I have multiple particle clouds here, and I have the particles here, the fireflies, affecting it as well. So this is like the worst case setup, and it's still only 3 milliseconds. So it's pretty decent. It does cost something, but it's pretty decent. If you were to switch this back to, say, only having standard volumetric fog without all the particle setup and the volume materials, to my test it's usually around 0.5 to 1 milliseconds to run this. I mean, it's perfectly doable. The more lights you add that affect the fog, for example, all these particle lights, all the fireflies, for every light that lights up the fog, it gets a little bit more expensive. So the expense kind of comes down to how many lights you have affecting this thing. And then on top of that, it comes down to how many particles with volume materials do you have and how complex is that material. So if you kind of be a little bit smart about things, you can get this to be very performant. Good. So let me just fly through, and then I'll that would lead to the end. So this is then the result. Just a small little 1-minute fly through. The reflection on the water, by the way, is too sharp for being in a foggy environment. You can tweak that with a setting on the sunlight. On the directional light, there's a property that says how wide should the specularity be spread. So you can fix that if I change that number. Yeah, and then this is the result. Cool. Thank you.